For the next few days, we are going to be working through some mixed problems. For the first two note pages for today, I would like you to try and answer the questions as you see them. And then, of course, I will reveal them and do some little bit of explaining. But there is another kind of step to the problems that starts on page 3 and goes to page 4. And so that we will walk through at a little bit of a slower pace. A bag contains 8 yellow marbles and 7 red marbles. What is the probability of pulling out a yellow marble? So you're finding the total possible outcomes, which you will add 8 and 7 to get 15, and the yellow are 8. Hopefully you got 8 out of 15. Feel free to pause if you are working through in your head or on a piece of paper before I reveal the answer. So the same question and same marbles, but this time you're looking at the probability of not pulling out a yellow marble. So we still have the same number of marbles, same number of total possible outcomes, and there are 8 yellow, so 15 minus 8 leaves us with 7. We have 9 marbles, and when they have the colors up, I'm just going to quickly review. I know we all know our colors, but it can be a bit questionable. So this is blue, gray, red, yellow, green, orange, purple, pink, and aqua. So when we refer to blue, we're looking at this one, the next. This one is the only pink one. This is orange and yellow. So just know that so we avoid any confusion. So what is the probability of pulling out a red or green marble? So we know that I have 9 marbles. Count up the 2 red and green ones. 2 out of 9. Now we have 9 cubes. What is the probability of pulling out a blue cube? So count the number of blue ones based on what I told you about the colors. 1 out of 9. A bag contains 15 yellow candies, 10 red candies, and 5 green candies. What is the probability of pulling out a red candy? So I'm going to add up all of the candies to find my total possible outcomes. Hopefully you also found 30. And I look and see in the question that there are 10 red candies. So the answer would be 10 out of 30. If you simplified that to an equivalent fraction, be 1/3. The box has 9 shapes. What is the probability of not pulling out a heart or a diamond? I know my total possible outcomes is 9, and I look through and I find 1 heart and 1 diamond, but I want to find out what is the probability of me not finding those. So 9 minus 2 is 7, and my total possible outcomes are still 9. What is the probability of picking a pink, yellow, or green flower? So I see 9 flowers, hopefully you do too, and find the pink, yellow, and green flower. Pink, yellow, green, 3 out of 9, and 1/3. What is the probability of picking a prime number? Possible outcomes, 9. And so there are 4 prime numbers, 2, 3, 5, and 7. Remember, prime numbers are ones that only 1 and itself can go into. Now composite numbers. Composite numbers can have a number that goes into it repeatedly, And so in this case, we have 4 again. We have 4, 6, 8, and 9. Even numbers. So count up your numbers and you have 4 even numbers out of the total possibilities of 9. Now how about odd numbers? We still are looking at total possible outcomes of 9. You should get 5, the 1, 3, 5, 7, and 9. What is the probability of the coin landing on heads? Now we know coins only have 2 options, heads being one of them, so it would be 1/2. Looking at the other option of tails, the chance would be 1/2 as well. What is the probability of picking a red kite or a blue kite? The first thing I need to do is count up my total possible outcomes. I have 3, 6, 9, 12, 15, 18. So out of the 18, I'm going to count up, and I found 1, 2, 3, and 4, counting up all the red and the blue kites. So 4 out of 18, simplified, can make it 2 out of 9. What is the probability of drawing a queen from a standard deck of cards? So we know that we have 52 cards in a deck, and there are 4 queens, 1 for each suit, so 4 out of 52 can be simplified to 1/13. What is the probability of drawing hearts and the number 2? So we know that there's only 1, 2 of hearts in an entire deck. There is more hearts and more 2s. However, both of them leaves us with 1 out of 52. The probability of drawing a suit. So you have a 4 out of 52 chance, simplified to 1 out of 13. The probability of drawing a red card is, we know that there are 2 red suits and 2 black suits, and each suit has 13 cards. You can also look at it if half of the cards are red, half are black. So it is 26 out of 52, and then 1/2. So this is where we are moving into more than one step to determine the probability. So Tom rolled the dice 120 times, and this table shows his results. So he got 35 times. When he rolled out of the 120, he got a 1, and such forth down here. And we want to look at how many times should each number on the dice have appeared. So knowing that our chance is 1 out of 6, and that we rolled the dice 120 times, if we did some multiplication and multiplied our probability of rolling a number 1 out of 6 times 120, we would find out how many times, if it was a perfect scenario, each number on the dice would show. So I can find out that 6 times 20 is 120. And so I multiplied the top by the same. 1 times 20 is 20 times. So this is a prediction of how many times each number should have been shown up out of 120. But of course, when you actually do a trial and experiment, that is not the case. Sammy tossed 2 coins 20 times. He recorded the outcome of each trial on the table. So his outcomes when he tossed 2, he could have gotten 2 heads, 1 tail, 1 head, or 2 tails. And you can see the results in the right column. So after 20 trials, how many times should he have received 2 heads? So just this outcome out of the 20 times. So we have a 1 out of 4 chance to multiply it by 20. 4 times 5 is 20. So we know that 1 times 5 is 5 times. So 5 times he should have gotten 2 heads. About 9 out of every 10 people are right-handed. The table below shows the number of students in Jason's class who are left-handed and right-handed. What is the theoretical probability that someone is right-handed? Write your answer as a percent. So when we talk about theoretical probability, it is kind of like, according to our calculations, this should happen. But we know that that is not always the case. So we know that 9 out of 10 people should be right-handed. And we always, to get a percent is 100, right? So per 100. So we can turn 10 into 100 by multiplying it by 10, because we know that 10 times 10 is 100. 9 out of times 10 is 90, 90%. 90% of people technically should be right-handed. What is the experimental probability that a student in Jason's class is right-handed? Write your answers as a percent. So now we're looking at actually what is going on in Jason's class. So 24 out of 25 are right-handed. And we can make it out of 100 by looking at the denominator and multiplying it to get 100. So we know that 25 times 4 is 100. So if you multiply the denominator by 4, you multiply the top by 4, 96%. So in actual life here in Jason's class, 96% of the kids are right-handed. There are 36 possible outcomes when 2 six-sided dice are rolled. You can roll doubles for 6 of these outcomes. So we already looked at a chart showing all the possible outcomes for dice. And so we already know that. Go back to review if you need to. So what is the theoretical probability of rolling doubles? So this means, according to the math, what should we get doubles? So we know that 6 out of 36 have the possibility for doubles, which is 1 in 6 chance. So again, the same information is presented, but this time we're looking at Jason, who rolled 2 dice 40 times and rolled doubles on 8 of these turns. What is the experimental probability of rolling doubles? What actually happened when Jason actually tried this out? So as it says, 8 out of the 40 times he rolled were doubles. And so 1/5 of the time. So the actual happening is a little bit different from previous 1/6, 1/5 of the time he got doubles.